Okay. So if we're gonna make a histogram, the first two words I want to pop in your head are bar graph. All bar graphs aren't histograms, but bar graphs don't pop in your head. All right? So you gotta have a frequency table to start with. If you've got one, you just praise Jesus and move on. Okay? If you don't have one, you still praise Jesus, but you gotta make it. All right? Now you got two axes, so to speak. I'm not calling them that. You'll see why in a second. The horizontal one, you put the class boundaries. Did I say limits? I said what? Boundaries. Okay, so we got another difference between the two. All right? And on the vertical scale, what have you got to put? The frequency. Now, I want you to put a note on this third one. This vertical scale must start with 0. Now, did I say the horizontal scale had to start with 0? No, I did not. But the vertical scale does have to start with 0 for your graph to have integrity. And all you're going to do is this. You're going to draw each bar to a height that corresponds to its frequency. Super simple, super easy. Okay. I'm going to draw each bar to a height that corresponds to its frequency. Now what we're going to do is, I'm going to just give a frequency table to start with, because I'm convinced now that you can make one if you have to. All right. And then we're going to draw different graphs off of the same table. Okay, so that you can kind of contrast. The problem would sound the same, but it would be different. Okay. All right, so you've got those steps in your notes. Okay. So let's move over here and do it while you're looking at your steps. All right, suppose this is my table. Let's just do a small one. You can do a small one in theory, you can do a big one. All right, suppose you had 20 to 24, 25 to 29, 30 to 34, and 35 to 39. Suppose this was 8 and 2 and 5 and 6. Okay, that was your frequency table. And I told you that you had to make a histogram. Now, what two words pop in your head when I say make a histogram? Barcode. All right, step one, if you got a frequency table.
Yes.
Yep, so that's good. So what am I going to do? I'm going to have this horizontal scale here. Now, what's got to go on this horizontal scale? Boundaries. So what's that mean you got to go do right now?
Find the boundary.
All right, so you got a calculator, so go find me those boundaries. Clean this board a little bit. Remember what we do, end of class 1, beginning of class 2. So what's the difference in these two things? 1, like Anna says, it always 1? No, but that's the most common. Now what am I going to do with that 1? Divide it by 2, so I get another 5/10, right? So what am I going to do with all of these upper limits in that 5/10? All right, so that's going to give me 24 what? 0.5. What's this going to be? 29 and 5/10. 34 and 5/10 and what? 39. Everybody okay on those upper boundaries? All right, what do I do with that 5/10 in these lower limits? All right, so what's 20 minus 5/10? So I get 19 and 5/10. Where'd that one come out to be? 24.5, 29 and 5/10, and So those red numbers, those boundaries go over here. So I've got a 19 5/10, a 24 5/10, a 29 5/10, a 34 5/10, and then a what, 39 5/10? Now, what's the class width on my table? 5. How'd you get that? Remind me. Any two vertical, 30 and 35 differ by 5, 24 and 29 differ by 5. Now, look at the boundaries. What are these boundaries differing by? 5. It better be the same. So these two boundaries better differ by 5 if the class width is 5. Now, this boundary and that boundary are the same. Now, this is a number line, so I'm not putting the same number twice on the number lines. Everybody with me? Okay? Now, that's my horizontal scale. All right, here's my vertical scale. Now, what have I got to start the vertical scale with?
0.
I just start with 0. Now, what's the biggest frequency that I've got?
8.
8. Now, 8's not very much, so I might go up by 1. But I guarantee you, if it were 80, I'm not going up by 1. Is everybody with me? Now, if I don't see any numbers, I'm going to assume you're going up by 1s. If you want to go up by 2s or 10s or 20s, you got to write those numbers down there. Is everybody with me? All right, so, I'm too lazy to write them all, but there you go. So that's what I mean by put your boundaries on the horizontal, put your frequencies on the vertical. Everybody good? Now this is another one of those things. Remember the one we just did from your homework? Did you get a lower boundary on the first class? It was a negative 5/10. So see, that first number might even be negative. That's why I don't call them X and Y axis. Because if these were X and Y axis, that would have to be the 0.00. And it doesn't have to be the 0.00. Okay? Now, do you understand that your first class, this is your lower boundary and this is your upper boundary? So your first class goes from 19 5/10 to 24 5/10. So between here and what? How high should I draw the bar?
8.
8. Now, what does the next one start with?
24.5.
24.5. What did that one end with?
24.5.
So what's going to happen with these bars? They're going to touch. Because this one goes from 24.5 to 29.5. How tall do I draw that bar? Just 2. Now the third class is from 29.5 to 34.5. See, 29.5 to 34.5. How tall does that one go up to? 5. And what about my last one? What does that go up to? 6. That's a sad looking segment, isn't it? That's a histogram. Okay. Now, do you understand if we'd use the limits would the bars touch? No, because one would have stopped with 24 and the next would have stopped with what? So there'd be gaps between these bars. On this histogram, there are not any gaps. That's why the boundary gets halved. What you're really doing is you're taking the gap between the two and you're halving it. And you're putting half on this bar and what? Half on that bar.
Why do we do that?
That's what histogram does, the bars need to touch, so that every piece of data, nothing can fall between anything. Okay, so we don't have anything falling between. Now, the only time that this will look a little weird, do you understand that if this had been a 0, I'm gonna fix it back, so don't erase your notes, just look up here. If that had been a 0, then what would have happened right here? What would it have looked like? It would look like something got skipped. Everybody with me? So that happens sometimes. You're like, oh, the bars don't touch. It's probably because there's not a bar there. Is everybody with me? Okay.
And that's okay.
And that's okay. But that's the only time they shouldn't be touching. Is if something happens, has a 0 frequency. I did put 2, didn't I?
Mm-hmm.
Okay. All right, so they're not hard. Now, do you understand that these bars should be the same width? Now, I'm not gonna get a ruler, but if you've got wide ones and skinny ones, I'm not gonna be happy. I'm gonna tell you to go to Dollar Tree and get your ruler. But as long as it's reasonable, I'm good. So that's what a histogram is. What two words pop in your head? Bar. Everybody okay? All right. The second kind of graph that I want you to learn to do is something called a frequency polygon. Frequency polygon. Now, I want two words to pop in your head this time, but it's not bar graph. This time I want to pop in your head line graph. Okay, line graph. Now, the first step's going to be the same. You must have a frequency distribution table. Okay, so the first step's the same on both graphs. So again, if you got a table, just be thankful and go on. If you don't have a table, then make one. You're smart. Now, on the histogram, what'd you put on that horizontal scale? Remind me. Boundaries. Not this time. This time I want you to put the midpoints. Now, technically, you can use midpoints on a histogram, but I think it makes them hard to read. Okay? And you have to use them on this. So it's a way to distinguish between the two. So midpoints go on the frequency polygon, boundaries go on the histogram. And again, you know how to find midpoints. I add them and divide by what? Okay? Now, again, on the vertical scale, you're going to put the frequencies again, and that vertical scale has to start with 0 on both graphs. So step 1 and step 3 are the same. Well, now obviously on step 4, I'm not going to draw bars because this isn't a bar graph. All right, what you're going to do this time is you're going to place a dot, like a point, above each midpoint at a height that corresponds to its frequency. Okay, so you're going to place a dot above each midpoint, and the height corresponds to the frequency. Now, there's going to be a couple more steps, but let's just kind of do the first 4, and then we'll come back and fill these in. Okay? So place a dot above each midpoint at a height that corresponds to its frequency. Okay? All right, so let's move over here then and do it. All right, and again, I'm going to have a horizontal scale and I'm going to have a vertical scale. So I got a horizontal scale here and a vertical scale. But this time, instead of putting the boundaries, what are we going to put? All right, so go find me those midpoints.
Are we using those same numbers?
Same numbers, we're using the same table. So we're going to have a histogram and a frequency polygon, two different pictures from the same data. All right, so this time, how did you get your first midpoint? What did you do with 20 and 24? You add them, so what's that get you, 44? And then you do what? Divided by 2, so what was your first midpoint? 22. All right, then you took your next two, your 25 and your 29, and you added those. All right, what'd you get, 54? Divided by 2, what'd you get for your next one? 27, what was your next midpoint? 32, what was your next one? 37. We agree on our midpoints. Now, what was the width on that table, remind me? 5. What did these midpoints differ by? 5. What did these boundaries differ by? 5. That's always gonna match if I've done them correctly. All right, so that's what I mean by put your midpoints on your horizontal scale. Now, what's this vertical scale got to start with? 0. And again, what height's it got to go up to? 8. Now again, you go up by ones, but like I said, if you'd rather go up by 2, 4, 6, 8, you're welcome to do that as well. Is everybody with me? I just got to see what you're going up by. Okay. If I don't see any numbers, what am I assuming you're going up by? 1. Okay. Now, what class is 22 the midpoint of? The first. What frequency is that first class got? 8. So right above 22 at a height of 8, what do I put? Dot. Jared?
Just to make sure like I'm getting this right.
Okay.
So you added 20 and 24 and got 44, then divided by 2, and that's how you get your
Yes.
midpoint.
Midpoint's always your lower limit plus your upper limit divided by 2. That's how you find midpoints.
Thank you.
You're welcome. All right, number 27, isn't that the midpoint for the second class? What height does that dot go? 2. The next one goes to the height of what?
5.
Now 5's gonna be halfway between 4 and 6, everybody with me? And then the last one goes to a height of what? 6. Everybody good? Now, it's supposed to be a line graph. How am I gonna turn that into lines? What am I gonna do with those dots? Connect the dots. That's your 5th step, connect the dots. All right, so go back on step number 5 and just write down connect the dots. So step 5 is to connect the dots, so that's what I'm gonna do over here. So this one gets connected to that one, gets connected to that one, gets connected to that one. Little seconds. Everybody good? Now, unfortunately, I did not name this, so do not get mad at me. This is called a frequency what? Polygon. All right? So Gracie and Katie and Morgan, you with me? All right? And Kaylee. A polygon's got 3 characteristics. And this one doesn't have all 3 characteristics. A polygon's got to be simple. Remember what the next phrase is? It's got to be what? You remember? It's got to be closed. And the sides are line segments. Now, I don't have a problem with simple. I can draw that without picking my pencil up. This is a line segment, that's a line segment, that's a line segment. What's wrong with it? It's not closed. So because it's called a polygon, I've got to fix that part. So the way that they fix it is your last step is, do you see this endpoint and this endpoint? You're just gonna drop down and connect them to this horizontal scale. All right, I'm literally just gonna take that point and connect it to this horizontal scale and take that point and do what? Connect that to the horizontal scale. Now that graph is closed. Is everybody with me? Now I'm gonna write this step over there in just a second. People will say, well, where do I connect it to? The author normally goes about half the distance, about half the width. I'm not gonna fuss as long as it just freaking touches. Everybody with me? All right. So this 5th step over here was connect the dots. And then your last step is, I just want you to connect the endpoints to the horizontal scale. So when you say frequency polygon, what two words pop in your head again? Line graph. When I say histogram, what two words pop in your head? Bar graph. What goes on the horizontal scale on the frequency polygon? The midpoints. Where do the boundaries go when it's a what? Histogram. Okay, so you gotta keep straight which one you want, all right? If it wasn't named what it's named, you wouldn't have to connect those endpoints, but it is. If you're gonna call it a polygon, it's gotta be a polygon, so it's gotta be closed. Okay? Now, if you were actually creating the graph yourself, then you could decide which one you thought kind of best represented your data. All right? To me, this one helps kind of show patterns, like the way things are trending. Does that make sense? Both of them show highs and lows pretty good. Okay? Now, for instance, next time what I'll do is show you, like, one of the things I do a lot is I go to the CDC website, the Center for Disease Control, and I go to the Mississippi Health Department website multiple times a week. All right? Because what I'm checking is, I'm trying to check the trend of the COVID numbers. I'm trying to see how they're trending. So for instance, my husband's a pastor. And so he's trying to explain to the Sunday school teachers why he's not comfortable doing in-person Sunday school. So right now they're Zooming it. All right, but he had to make his case. So he's like, what kind of graph? This one. Only they don't know it's called polygons. Everybody with me? So he didn't bother to connect. You see what I'm saying? But you can look at the active cases in the county, and they are literally, since COVID, they were doing pretty good. We're tracking up. So the reason we had in-person Sunday school here isn't happening here. Is everybody with me? So with that more contagious variant, the number of cases is naturally probably going to what? Climb up. All right? In a college town, when students come back, guess what those cases do? Y'all gonna kill me dead. You know what they do? They go up. All right, same thing. If elementary and secondary schools are virtual, usually the cases kind of trend what? Down a bit. When they go back in person, what happens to them? They go back what? Up. We're gonna kill all these teachers now. So, you know, when you want to argue a case, for him to just throw numbers at those people, they just get overwhelmed. Everybody with me? But they can see very clearly, oh my gosh, this is tracking up. So since there are a fair number of senior adults, this would be reckless. Is everybody with me? Now, if you're a church that's mostly 20-year-olds, maybe not. But if, you know, when you got old people like me, you go kill somebody. You can't be doing that. You know, you want to see Jesus, but not today. Okay. So you got to kind of know your audience and kind of, but you have to justify decisions that you make, whether you're the pastor of a church or a CEO or a school principal or anything else. Okay. All right. So that was my daughter teaches school in New Orleans. So she's an officer in the teachers union. And so one of the things she had to do was prove at one point why they needed to flip to virtual. So you can't just go, I think this is my opinion, she had to go, you know, we had to go gather data, get some graphs, kind of showing what was happening. Okay? All right, now there's a third kind of graph that I want you to be able to do. All right, now let me show you a couple things in your book before we do this third kind though. All right, look in your books on page 51. All right. Now, what do the two graphs at the bottom look like? They look like what kind of graphs? They are histograms. Now, here's the difference in the first one's a regular histogram. What's different about the first graph and the second graph? They look the same, and they really are the same, except what's different about the vertical scale? Percentages. When they've got percentages instead of actual frequencies, that's called a relative frequency histogram. Everybody with me? I'm not going to make you draw one of those. Do you see that the picture looks the same? Is everybody with me? But they do percentages rather than actual numbers. All right. Now, look on page 52. It says common distribution shapes. Now, do you see that all four of those pictures are histograms on page 52 in your book? Now, let me show you something that your book's gonna ask you. In lots of places, especially education, there's a curve called a normal distribution, all right? The last third of the class, you're gonna hear normal distribution in your sleep, okay? All they do right now is kind of introduce it, all right? A normal curve, a lot of times in education, they call it a bell-shaped curve, all right? Now, here's what a bell-shaped curve kind of looks like. It looks like this. It's called bell-shaped curve, kind of a bell. Now, what's true about it is, in the dead center is your highest point, and this thing is symmetric. So this side's a mirror image of that side. Is everybody with me? So it gradually goes up and what? Gradually comes back down. Now, we're going to talk about later, there's certain percentages associated with it. But one of the things that your author's going to ask you on your homework is, does this histogram approach a normal distribution? All right, do you see the green one in your book on page 52? It looks sort of like this. Yeah. Now, the blue and the brown one looks sort of like it, but what's wrong with them? They're what they call skewed, like the hump's not in the middle. Is everybody with me? Now, once again, don't blame me. All right, because for some reason, the way they're worded is counterintuitive for me. It may not be counterintuitive for you. I would have worded them backwards. Here's what I mean. You see this one's like a normal curve on a really bad day. All right. If I had been naming it, what would you have named it? Skewed which way? It's skewed to the right. See, you're like me. It's where the tail is, not where the hump is. All right. So this one's called skewed to the what? Right. That one would be skewed to the what? So it's not where the hump is, it's where the what? So say so I don't feel so bad about myself. Okay. So there's what you to kind of notice, because that's one of the things they're going to be talking about later is does this data look sort of like a normal distribution? Because a normal distribution's got a whole lot of properties later in the semester that are special to it. Okay. Now, all right. Now you can have other kind of bar graphs. You can have double bar graphs, like flip on page 60 in your books. Do you see that at the top? Bar graph, but there's a bunch of reasons it's not a histogram. Here's one thing. What's on the horizontal scale? Numbers or words? Words. That's a breadth chart. Okay. Look back on page 59. Why is that not a frequency polygon? What's one problem? It's not connected to the axis. Everybody with me? And I got to say, with those midpoints, I don't know. All right. So there are going to be some other graphs that I'm not going to make you draw. Is everybody with me? So all bar charts aren't necessarily histograms. All line things are necessarily frequency polygons. But that's the two you got to draw so far. All right. Now, the third one I'm going to make you draw is called a circle graph. Now, your book calls it pie chart. Mathematicians call them circle graphs. So there we go. All right. So making a circle graph. Now, this one we're going to kind of do as we go, rather than writing all the steps down and then doing it. Now, I'm just going to pull that frequency table that we've been using, so you've got all three graphs off the same table. Okay. I'll give you. Guess what the first step is? That's right. You have to have a frequency table. All right. Then it's different. Must have a frequency distribution table. But obviously, if I'm going to have a circle graph, I'm not going to have like an x-axis kind of thing and a y-axis. Everybody with me? So this one's going to be different. Okay. But if you don't know at least the first step, when you have to make a graph for me, you know, we got a problem. Okay, like you're just not super bright, okay? Now, here's your second thing I want you to do, though. I want you to total the frequencies. When I say total, what am I wanting you to do? Add them, all right? So total the frequencies. And the reason I'm using the word total is because I want you to literally write down total, so it's easier for me to follow. If you like scratch work, you want to make your work easier for me to follow, so you get as many possible points as possible. If you don't care enough to make it neat, I don't care enough to be partial. Okay, so what's my total here? 21. Okay. Now, what I'm going to do is I'm going to get some decimal numbers next. Okay. And the way I'm going to get those decimals is this. I'm going to divide each frequency by that total. Now, you'll see why I'm doing this in a second, but I'm going to round to the hundreds if I need to. Now, how many numbers to the right of the decimal is the hundreds? 2. Now, I didn't say terminate, I said rounds. Everybody with me? So do you understand if I were to get like 0.353, would that be 0.35 or 0.36? Point what? 35, because that's smaller, right? Now, if it were 0.358, it'd be point what? 36. So we're not going to chop off, we're going to what? Round. And we're not rounding up, we're just rounding what? Off. Okay, so you might want to put, round off. I'm not rounding up, I'm rounding off. Okay? So you understand what I'm about to do with my calculator? I'm going to take this 8 and divide it by what? 21, am I not? All right, so you take your calculator. I'm not going to be working your test for you, so you need to be doing it yourself. And tell me what I'm going to round to. Everybody agree with 0.38? Because it's 0.38. What's the next number on your calculator? Isn't it a 0? So because that number is 4 or smaller, that stays the same. So I've got 38 hundredths for that one. All right, how am I going to get the next one? What am I going to divide by 21? 2, right? So you take 2 and divide by 21. Now, what am I going to get there?
0.96.
Okay. Keeps going, doesn't it? Now I want 2 numbers to the right, do I not? Oh, it's 0.09, isn't it? Mm-hmm. Now, what's this number make that one do? Go up from 9 to what? To 10. Everybody with me? So what's going to go right here? 0. Point what? 1, or I'd even put what? I'd put 10. Everybody okay? How am I going to get the next one? Am I going to divide by 21? All right, so 5 divided by 21, is that going to be 0.23 or 0.24? 24. And 6 divided by 21, 0.28 or 0.29? Now, if you round them incorrectly, I'm going to count off. Now, here's a way to kind of sort of check yourself. What should these add up to about?
100 or 1.
About 1. Why might they not exactly? Because you rounded, so you'll get a little bit of errors. Everybody with me? Now, we're going to do 2 different things with these decimal numbers. The first thing I want you to change those decimals to percents. How do you change decimals to percents? All right, so to get percents, you're going to multiply those decimals by 100. So I'm keeping this table going. This is easy to kind of follow. So what's 3,800 times 100? What's that gonna give me? 38 what? Percent. That's why I rounded to the 100, so you would just get whole numbers. Okay? What's this gonna be? 10%. What's this one gonna be? 24% and what? 29%. And again, what should that add up to about? 100. Now, this one isn't. I can already tell because 8 and 4 is gonna be a 12, right? And the 9 is gonna end in a 1. It's gonna be like 101. Why might it be 101? Because I did a little bit of what? Rounding. So you might get a 98 or a 99 if you have a lot, or you might get a 101 or 102, but anything else, probably not. Okay? So one thing you gotta do with those decimals is you gotta turn to percents. Now, here's the other thing you gotta do with those decimals. You gotta turn those decimals into angle measures. Angles. So I'm gonna go back and I'm gonna use this same decimal column. So I did these decimals times 100 to get the percents. Now, I'm going to what kind of picture of what? Circle. How many degrees in a circle? 360. So what am I gonna multiply these decimals by now? Not 100, but 360. So step 5 is to get angle measures. You're gonna multiply those same decimals by 360. All right. So step 4 is to get percents. You multiply those decimals by 100, and your next step is your last to get those angle measures multiplied by 360. So go back to those decimals for me right now and multiply them by 360 and see what you think those angle measures are. I'm going to take this 0.38 and I'm going to multiply by 360. Now, because we're just kind of getting a general idea, you can round to the nearest whole number if you want to. So is that going to be 136 degrees or 137? 137, okay? So what's 0.10 or 0.1 times 360 going to give me? 36 degrees. Then I've got 100 times 360. So what angle measure are you going to write? 86 or 87?
86.
86. And then 29 hundredths times 360. What am I going to write down? 10 what? 4. Would you want us to round? Yeah, I would just use rounding off to the whole number. Okay. Now again, what should those angles add up to be about? About 360, right? But again, they probably won't here because we rounded. They might, but they might not. But it should be close. Everybody good so far? Now, here's your choice. Now, let me preface this. If I were really doing this in the real world, I would make sure I had a protractor. Everybody with me? But this is, as long as it's close enough, I can be satisfied. Now, if you're gonna stress, get a protractor. You should be able to get one for like $1. Okay? But with COVID, who knows where they are? All right? So rather than getting an Amazon shipment for $1, everybody with me? Now, I want a rough sketch. Now, if your rough sketch is too rough, you'll get a note that says, go buy a protractor. Okay? So here's what I mean. Your last step is you draw the circle graph. So step 6 is just draw the circle graph. Now, let me show you what I mean by a rough sketch. All right, first of all, what shape is it supposed to be? Now, again, if I were really doing a presentation, I'd be doing this on a computer program, but I'm not. So I'm gonna draw a circle. All right, it's not too bad for a freehand one. Now, there's some angles I expect you to know. What's a 90-degree angle look like? A right angle, like a corner, right? What's 180? Straight across, right? So you should be able to judge off of those two things. So here's what I mean. My first angle needs to be what? 137. So do we understand that that right there would be 90? If it went straight, what would it be? 180. It's 137, about halfway between the two. Is everybody with me? So to me, that's reasonable. Now, if I finish the graph in a minute and I don't think it's reasonable, I will erase and adjust, and you should be doing everything in pencil. Inside this piece of pie, I want the class. I'm gonna get your angle measures and your percents from your scratch work. If they're missing, I will not take your picture. Like you can't go, that's about 38% of the circle. If I don't see an angle measure, I won't take it. Is everybody with me? Now, here's the advantage that you have that I don't. Now, this may be hard to see on Zoom, all right? But I've got this. I can't turn the board around. But you can take your paper and do what? Turn it around. Is everybody with me? Because where this one ends, the next one what? Starts. Now, what angle measure is the next one supposed to be? 36. Now, again, do we understand that if I went like this, that would be a right angle? But it's easier if you turn it. Is everybody with me? Now, what if I halved that? What if I halved it? That would be what? 45. Is everybody with me? See, that's what I mean by freehanding. Is everybody okay? I need to be a little what? Less than that. Now, let me show you what I mean by adjust. What happens when you add these two? What's that get you?
173.
173. So shouldn't it be a little less than straight across? And I might say, well, I think it needs to be just a little bit wider. Okay, I mean, but it shouldn't be straight across or more than straight across. Everybody with me? So that's what I mean by it's just got to be in the ballpark. So what class is this? 25 to what? 29. Now, what's my last, what's this third class got to be? Now, remember, wouldn't that be about 90? Everybody with me? I need mine to be a little what? A little less. Now, I'm going to show you why I would adjust it a little bit if it were me. This is supposed to be, what is it, 30 to 34? And this is supposed to be, what is this one, 35 to what? 39. What's supposed to be the biggest piece? Is it this one? See, to me, this one and this one look a little too close. Is everybody with me? So I'd probably make that one a little bit smaller. Let's a little bit. But if you've already got a protractor, it's really just quicker to use the protractor. Is everybody with me? But if you don't, and you want to freehand it, freehand it. But I mean, if you tell me that that is 136 degrees, I'm going to tell you you're 137, I want you to go by a protractor. Everybody with me? Or if you start trying to tell me that that is 50 degrees, I'm going to tell you to go by a what? Protractor. All right. So that's the three different kinds of graphs you got to be able to draw so far. Is everybody with me? So when I say histogram, what two words pop in your head?
Bar graph.
Bar graph. When I say frequency polygon, what pops in your head?
Line
Line graph. And then surely when I say circle graph pops in your head. Now, like I told you, they show you some other graphs in your book that I'm not going to make you responsible for, but I do want you to look at them for a second. Look on page 58. Do you see where they have something called a dot plot? A dot plot is really, it's a number line, and you actually represent your data with the dot. How many dots are above 50? So how many 50s were in the list? 2. Is everybody with me? Do you see there's like 1, 2, 3, 4 dots between 50 and 60, like horizontally? So that means that's a 52, if you see what I'm saying? So when you have multiple times, multiple frequencies of the same number, they just stack the what? The dots. So if you had 4 75s, you'd have 4 dots above what? 75. So again, you can see the actual numbers that occurred most. So that's what a dot plot looks like. Now, next time I'm going to show you how to make a stem and leaf. So you are going to have to make a stem and leaf. All right. Look on page 60. That's a pie chart, but we're not going to make one like that because instead of having classes, they have categories. But you can have pie charts that have words. All right. They also show you on page 62, sometimes they will do relative frequency polygons. Remember what was a relative frequency histogram? What was on that vertical scale? Percent. So again, what's on this scale? Percent. Sometimes they'll put double bars if they want to compare like male to female or, last year to this year. They do a lot of that sometimes. For instance, on those COVID graphs, a lot of times they'll put hospitalizations and a second line graph will be ICUs. Because ICUs can fill up faster than just the what? Hospital or vice versa. Is everybody with me? So there's several things they want to know, not just one piece of information. Pictographs are okay, but you can distort a pictograph. Like the bottom of page 63, we'll talk about that later. Like you'd have as a kid, every apple represents 5 people or something. Okay? So far you've got 3 graphs, a histogram, a frequency polygon, and a what? Circle graph. Next time we're going to get a stem and leaf, and then toward the end, you're going to get a different kind of graph, but we're going to do that for a little bit. Now, I'm warning you on your homework, you need to make sure you read the directions I put on Moodle, because I may be changing the directions in the books. Everybody with me? I'm probably at least going to give you, go look at this certain table and do all 3 graphs off of it. All right, so where are you going to check your homework? Maybe I'll see y'all on Zoom. Some of the other